Hello everyone, Reese Robinson here from the Grundfos Technical Institute. Today I'm going to show you how to set up proportional pressure control with a Hydro MPC system with a CU352. So we're going to zoom in on the controller here so you can get a better view of that, and we'll go from there. So here we are with a close-up of our CU352 controller. As you can see, we've got a system with 3 pumps here. We've got pump number 2 running at about 85% speed, suction pressure of about 29-30 psi, discharge pressure of 65. So 65 psi is our set point pressure, and then our PV, that's our sensor signal coming back, so that's our process variable. So we're maintaining a 65 psi set point. We've got an approximate flow rate of 26 GPM, and our power is 1 kilowatt. Power is the notable item on the screen here, because right now, with one pump running at low flow, we're using 1 kilowatt of energy. So the intent of proportional pressure is to reduce the energy at low flow, outputting a lower pressure because that higher pressure is not needed because we have less friction in our piping. So what we're going to do is we're going to enable proportional pressure control. So we're going to hit our right arrow key here and go over to settings. And then within settings, we're going to go into primary controller where proportional pressure is found. As you can see, there's other choices here. So we're going to go into proportional pressure. And so the first thing we need to do is enable it. So if we don't enable it, we're not going to get it. So we're going to enable proportional pressure control. And then down here under adaptation, we need to choose between linear and squared. If you're not sure what either one of those is, there's another video explaining proportional pressure. It's done on a whiteboard with pump curves and diagrams so you can see what that is. So you can watch that at the conclusion of this video, then you'll understand what the difference between the two is. And what you'll find is that squared is actually going to be more energy conscious than the linear one. So influence at zero flow, our set point is 65 psi. So how low do we want the pressure to be reduced as flow approaches zero? That's going to depend on your system. But for today's example, we'll set that down to 75%. So what that means is that if I set this at 75%, the set point as flow approaches zero will be 75% of our system set point, which is 65 psi. So at zero flow, it'll be approximately 49 psi, our adjusted set point. And we'll see that in a minute. And filter factor is if you have a flow transmitter, so if you're utilizing a flow transmitter for flow measurement, sometimes those signals coming in will be kind of choppy, they'll bounce up and down. So filter factor will enable you to smooth that out. We are currently using the calculated flow, so this doesn't apply to our situation. The max flow, the QP max, we're going to use the pump curve to establish the max flow. 3 pumps running at 100% will result in a max flow rate of, if I hit here to use pump curve, it'll actually tell us. So with our current set point and the 3 pumps that are on this system, our max flow is about 126 GPM. That's because our pump curves are loaded up into the controller, so we know what our max flow rate is. That's where your proportional pressure curve starts. If you wanted to customize your proportional pressure, in other words, start it at a lower flow rate, you could do that by going here, hitting enter value, and then we can adjust that down to a specific flow rate. So we'll choose 125, for example. Then it would start that control curve at 125. We're going to go ahead and use the pump curve. That's the most common. So actually we've done everything we need to do to set up proportional pressure control. So if we hit our home button here that takes us back to our main status screen, we will now see that our new set point is 49 psi. Our flow rate is a little bit lower now. It's starting to get closer to zero. But mainly we see that we've reduced our power down to 0.5 kW. So with that proportional pressure, we had about a kilowatt of energy at low flow. We're now down to a half a kilowatt. So you can see the energy savings impact of this. And there's also a message here that says proportional pressure influence active. That's letting the operators know that we have deployed proportional pressure. So now they know why the set point's not 65 right now, it's actually 49 because we're at low flow rate, saving lots of energy.